In our world today, everything's connected, right? And AI is just exploding. Staying secure, well, it's not just a good idea anymore. It's essential.
Absolutely. And today we're diving into something that really drives that point home, a specific weakness found in a really popular tool.
We're talking about Langflow, right?
Exactly. Langflow, you might know it. It's this open source framework. Think of it as like a drag and drop way to build AI applications, chatbots, workflows, that kind of thing.
So you don't need to be a hardcore coder to use it.
Pretty much. That's the appeal. And it's huge on GitHub. Loads of people use it. And it's got backing from some big names too, like DataStax, IBM.
Yeah.
So it's definitely relevant.
Which makes this vulnerability CVE 2025-3248 particularly interesting. So our goal today is, well, to unpack this, understand what it is, what it could mean, and crucially, what you need to know about it.
Yeah. And at its core, it boils down to missing authentication, a failure to check who's actually allowed to do certain things.
Which in this case could lead to attackers running their own code remotely.
That's the scary part. Remote code execution, potentially without needing any login details at all.
Okay, that's serious stuff. Before we really get into the weeds, though, let's quickly thank our sponsor. This deep dive is brought to you by Stonefly.
Right, Stonefly. They're leaders in enterprise storage, backup, disaster recovery, AI storage, the whole cloud solutions space.
And if you're thinking about security, especially ransomware protection, they offer things like air-gapped and immutable storage. Really robust options.
Definitely worth checking out. You can contact them at sales@stonefly.com to schedule a demo.
Okay, so back to this Langflow vulnerability. How did this even get discovered? Who found it?
It was the security research team over at Horizon3.ai. And what's interesting is how they looked for it.
Oh, what was different?
They approached it from the perspective of like an unauthenticated attacker, someone just poking around from the outside, even on systems that supposedly had authentication turned on.
Ah, simulating a real-world internet probe, basically.
Exactly, because that's how these things often get found in the wild, right? Someone scanning for any open door.
Makes sense. So where did they find this open door in Langflow? What specific part was vulnerable?
They pinpointed it to a specific API endpoint, the P1 validate code.
Okay, a P1 validate code. What was that supposed to do?
Its job was basically to check code snippets, validate them, make sure they were syntactically correct, presumably.
But the problem was?
The problem was it didn't ask who was asking. There was no authentication check. It just did the validation for anyone who requested it, wide open.
An unlocked door, just like you said. Okay, but how do you get from validating code to running your own malicious code? That seems like a big jump.
It does, but here's where the technical detail comes in. The underlying issue is tied to Python's exec function.
Exec. I know that one. It lets you run Python code stored in a string, right?
Exactly. And Langflow was using exec on code supplied by the user, or in this case, the potential attacker, via that unsecured endpoint. And critically, without enough checks to sanitize or restrict what that code could actually do.
Ooh, yeah. Running exec on untrusted input is generally a bad idea unless you're really careful.
It's playing with fire, basically, and the researchers found some clever ways to exploit this lack of caution.
Okay, I'm intrigued. What were the methods? How did they weaponize this?
They highlighted two main techniques. The first one involves abusing something called Python decorators.
Decorators. Those at symbols you put above function definitions.
That's them. Think of them as code that wraps or modifies another function. Now, the clever or dangerous part is when decorators run. They're executed when the function itself is defined, not when it's called.
Ah, okay. So even before anyone tries to use the function.
Precisely. So an attacker could craft a function definition with a malicious decorator, send it to that validate code endpoint, and boom, the decorator code runs on the server immediately as Python processes the definition.
Wow. Can you give a simple example of what that might look like?
Sure. Imagine something like exec. Import os.system echo hacked fsmfunction.pass. If Langflow processed that definition string through the vulnerable endpoint, that exec in the decorator would run the command echo hacked right there on the server. The sum function itself is irrelevant and never needs to run.
That is sneaky. It runs just by being defined. Okay, what was the second method?
The second method exploits function default arguments. Similar idea, really.
How so?
Well, default arguments in Python, the values assigned in the function definition, like myfunc, are giving them some value.
Yeah.
Those default values are also evaluated when the function is defined.
Oh, I see where this is going. Same timing issue.
Exactly.
Right.
An attacker could embed malicious code within a default argument using exec, something like def exploit func cmd exec import subprocess.pass, When Langflow defines this function, that exec runs, executing the ed command, for instance.
So both methods leverage the fact that code gets executed during the definition phase, not just when a function is called.
You got it. And the crucial point is, because that endpoint was unauthenticated, an attacker could trigger this just by sending the crafted code definition. No login needed.
Okay. Remote unauthenticated code execution. That spells trouble. What are the actual consequences? If someone pulls this off, what can they do?
Well, the impact is severe. Remote code execution means the attacker can essentially run whatever commands they want on the Langflow server.
So they basically own the box.
Pretty much. It can lead very quickly to a full system compromise, complete control over the machine.
And once they have that control,
The sky is the limit, unfortunately. They could mess with system integrity change files, delete data, they could steal sensitive information, anything stored on or accessible from that server, confidentiality is gone.
and they could just shut things down, disrupt services.
Absolutely. Availability is compromised. They could crash Langflow, maybe even hold the system for ransom. But remember, this bypasses normal login, so it might get around other security layers you thought were protecting the system.
This is sounding worse and worse. Is this just theoretical, or are people actually doing this? Is there evidence of it being used in the wild?
Unfortunately, it moved beyond theoretical very quickly. Once the technical details and, crucially, proof of concept exploit code became public,
The risk skyrockets, right?
massively. And then we saw data from Senses, the internet scanning service, showing hundreds of Langflow instances just sitting there, exposed directly to the internet. A huge potential attack surface.
Hundreds, wow. That's a lot of potential targets.
It is. And then, almost immediately after the POC dropped, the SANS Technology Institute started seeing exploit attempts hitting their honeypots.
Honeypots, those decoy systems. So attackers were actively trying it out.
Yes, active attempts were detected very quickly. And some of those attempts were trying to grab files that often contain passwords, like etc. password. So it wasn't just testing, it was reconnaissance, trying to steal credentials.
Concrete evidence of active exploitation.
Yeah.
That definitely raises the urgency. Has this caught the attention of, like, official bodies?
Yeah.
Government agencies?
It has. CISA, the U.S. cybersecurity agency, added this vulnerability CVE 2025-3248 to its known exploited vulnerabilities catalog, the KEV list.
That's significant, isn't it? Being on the KEV list.
It's very significant. It means CISA confirms it's being actively exploited and mandates that U.S. federal agencies patch it by a specific deadline. And while that mandate is for federal agencies, CISA strongly recommends all organizations prioritize patching KEV vulnerabilities.
Okay, so the message is clear. If you're using Langflow, you cannot ignore this. Is there a fix? What's the solution?
Yes, thankfully, the Langflow developers responded. Version 1.3.0, which came out on March 31st, 2025, specifically addresses this.
How does it fix it?
It adds the missing piece.
Yeah.
Authentication is now required for that AP1 validate code endpoint. You can't just hit it anonymously anymore.
Right. So the number one action item is upgrade to 1.3.0 or later. How do people check their version and do the upgrade?
Usually, the version number is visible somewhere in the Langflow interface, maybe an About page or Settings. If you installed it using pip, the Python package manager, upgrading is typically straightforward. Open your command line and run pip install upgrade Langflow.
Simple command, pip install upgrade Langflow. That's the critical first step.
Absolutely critical. Do it immediately if you're on an older version.
Now, besides upgrading, are there other things people should be doing? Best practices, maybe? Defense in depth.
Definitely. Patching is vital, but layering security is always smart. A big one is network access control. Don't expose Langflow directly to the public internet if you don't absolutely have to.
So use firewalls, maybe put it inside a virtual private cloud, VPC.
Exactly. Limit who can even reach the application. And even if it needs some exposure, put strong authentication in front of it, like single sign-on, SSO.
Even though this specific flaw bypassed auth, strong auth is still good practice.
Right. Also, think about network segmentation. Isolate Langflow from other critical systems and use access control lists, ACLs, to be really specific about who or what can talk to that F21 validate code path even after patching.
Tighten the screws on that specific endpoint. Makes
Yeah.
sense. What else?
A web application firewall, a WAF, can help. You can configure WAF rules to look for and block attempts to inject malicious code patterns.
Another layer of filtering.
Yep. And of course, good monitoring and logging are essential. Keep an eye out for any weird activity on your Langflow servers. If something does get through, you want to know about it fast.
And finally, test the patch first.
Always a good idea if you can. Test the upgrade in a staging environment before rolling it out to production, just to make sure nothing breaks unexpectedly.
Great advice. Now, I remember reading something. The researchers at Horizon 3.ai, even after the patch, they had some lingering thoughts or concerns.
Yes, that's a really important nuance they pointed out. While the patch fixes the unauthenticated access issue by adding the login requirement, they observed that the underlying capability for authenticated users to execute code via mechanisms like this still sort of exists within Langflow's design.
Ah, so if someone does have valid login credentials, maybe a compromised account, they could still potentially run arbitrary code.
That's the concern they raised. They drew a distinction between, say, regular users and admin or super users in Langflow, but noted that even regular authenticated users might still have this code execution capability inherent in the platform.
So the immediate fire, the unauthenticated RCE, is put out by the patch,
Yeah.
but there's still this underlying design aspect that requires careful management.
Exactly. It means things like robust password policies, multi-factor authentication, and especially the principle of least privilege become even more important. Don't give users more permissions than they absolutely need to do their job.
That really adds another layer to think about, especially for organizations using Langflow for critical tasks.
Yeah.
Okay, let's try and wrap this up. What are the absolute key takeaways for our listeners from this whole CVE 2025 3D248 situation?
Number one, this was, and potentially still is, if unpatched, a critical vulnerability. If you use Langflow version prior to 1.3.0, immediate action is needed.
Don't delay.
Don't delay. Remember, it was unauthenticated remote code execution. Attackers needed no password. It was proven easy to exploit with public tools, and the impact is severe full system compromise, data theft, the works.
But there's a fix.
Yes. The fix is in version 1.3.0. Upgrading is paramount. Apply the other security layers too: network controls, auth, WA, monitoring.
And beyond just Langflow, does this teach us anything broader, especially with all these AI tools popping up?
I think it really underscores the risks inherent in tools that execute dynamic code, particularly code that might originate from users or external sources. Secure coding practices, thorough testing, and assuming untrusted input are just vital.
Especially for tools exposed to the internet.
Absolutely. The convenience of these powerful AI and automation platforms comes with responsibility. Security can't be an afterthought in this rapidly evolving landscape.
Which leads to a final thought for you, our listener, to maybe chew on. We're seeing this incredible explosion of AI development tools. They offer amazing capabilities,
Right.
but how do we balance that rapid innovation with the need for robust security? How can your organization make sure you're not just adopting powerful tools, but also securing them effectively against threats that are also constantly evolving? It's a big question.
It really is. And that brings us to the end of this deep dive. The key, as always, is staying informed, being proactive, and layering those defenses.
Well said. And thanks again to our sponsors, Stonefly. They're leaders in enterprise storage, backup, disaster recovery, AI storage, and cloud solutions.
And remember, if you need truly secure storage, especially against ransomware, check out their air-gapped and immutable options.
You can schedule a demo and find out more by contacting sales@stonefly.com.